Hello everyone, welcome to my TinkerCad collection. So this is my collection about circuit. And here we're going to look at our first project, which is actually LED flasher, but I entitled it as red LED. So this is how it looks like. We will be clicking this simulate and it will simulate just like. We start the simulation. Initializing, and it will light up just like that, like an ordinary flasher. The long LED is the anode of the LED, always must go to the positive 5 voltage of supply, and the short is cathode, must go to the ground. Now this is our coding. You can pause the video and look further into it. Now let's go and see our second project, SOS Morse code signaler. Okay, let's press simulate to see how it's simulating. Alright, while waiting, let me show you this is how it looks like in the diagram. Okay, loading. For this project, we are going to leave the exact same circuit set up as in project 1, but we'll use some different code to make the LED display a message in Morse code. In this case, we are going to get the LED to signal the letters SOS, which is the International Morse Code Distress Signal. Morse code is a type of character encoding that transmit letters and numbers using patterns of on and off. It is therefore nicely suited our digital system, as we can turn an LED on and off in the necessary pattern to spell out a word or a series of characters. In this case, we will be signaling SOS, which in the Morse code alphabet is the 3 digits, short flash, followed by the 3 dots, long flash, followed by 3 digits again. We can therefore now code our sketch to flash the LED on and off in this pattern signaling SOS. Now we will initializing the simulation. As you can see, it flash according to the short digits and long dots. Now let's check the coding. Okay, now let's see our third project, which is the traffic lights, which we will be create a set of UCAD traffic lights that will change from green to red via amber and back again after a set length of time using the 4-stage system. This project could be used on a model railway to make a set of working traffic lights or for a child's toy town. This time we have connected 3 LEDs with the anode of each one going to the digital pins at 9 and 10 via a 150 ohms resistor each. We have taken the jumper wire from ground to the ground rail at the top of the breadboard, and the ground wire goes to the cathode leg of each LED to the common ground rail. Therefore, let us start to simulate it. Now let's start the simulation. As you can see, the red lights is flashing. Followed by the yellow LED and green LED. Then it will change back to yellow in a few seconds. And then it will back to the red one. That's how our traffic light works. You can see the coding. As you know, you can pause the video to check one by one. That's it. Now in the next project, we are going to add this project by including a set of pedestrian lights and adding a push button to make the lights interactive. I forgot to change the title, but it's actually project number 4, named Interactive Traffic Lights. Now the additional components here is additional LEDs with colors and tactile switch. So this time the Arduino will react when the button is pressed by changing the state of the lights to make the car stop and allow the pedestrian to cross safely. As you can see, when I push the button, the traffic lights change their lights. This means the cars need to stop and the pedestrians are able to walk. Now let's see at the coding. As usual, you can pause the video to see one by one. Now we're going to our 5th project, which is LED chase effect. We are now going to use a string of LEDs, 10 in total, to make an LED chase effect, similar that used on the car KITT in the Knight Rider TV series, and on the way introduced the concept of arrays. Alright. Let's see how it simulates. Now as you can see, the chase effect is occurring right now. Now we are going to our 6th project, interactive LED chase effect. The same breadboard, the same components, the same resistor and the jump wires, with an additional potentiometer of 4K7 ohms. Okay. Now the potentiometer has 3 legs. By connecting up just 2 legs, the potentiometer becomes a variable resistor. By connecting all 3 legs and applying a voltage across it, the pot becomes a voltage divider. This is how we have used it in our circuit. One side is connected to the ground, the other to 5 volt, and the center pin to our analog pin. By adjusting the knob, a voltage between 0 and 5 volt will be leaked from the center pin, and we can read the value of the voltage on analog pin 2 and use its value to change the delay rate of the light effect. Now the potentiometer can be very useful in providing a means of adjusting a value from 0 to a set amount. An example, the volume of a radio or the brightness of a lamp. In fact, dimmer switches for your home lamps are a kind of potentiometer. Now we're going on to our 7th project, which is the pulsating lamp. We are now going to delve further into a more advanced method of controlling LEDs. So far we have simply turned the LED on or off. How about being able to adjust its brightness too? Can we do that with an Arduino? Yes, we can. So verify and upload. You will now see your LED post set on and off steadily. Instead of a simple on or off state, we are now adjusting its brightness. Let's find out how this works. The concept here is that we are creating a sine wave and having the brightness of the LED follow the path of the wave. This is what makes the light pulsate in the way instead of just fade up to full brightness and back down again. Next, we're going to project add our mood lamp. In the last project, we saw that we could adjust the brightness of an LED using the PWM capabilities of the AdMaker chip. We'll now take advantage of this capability by using a red, green, and blue LED and by mixing the colors to create any color we wish. From that, we will create a mood lamp similar to the kind you see for sale all over the place nowadays. Actually, by adjusting the brightnesses using PWM, we can get every other color in between too, like cyan, magenta, and white. By placing the LEDs close together and by mixing their values, the light spectra of the three colors added together make a single color. Now we're going to the ninth project, which is LED fire effect. Project 9 will use LEDs and a flickering random light effect using PWM again to recreate the effect of flickering flame. If you will place these LEDs inside a model house on a model railway layout, for example, you could create a special effect of the house being on fire, or you could place it into a fake fireplace in your house to give a fire effect. This is a simple example of how LEDs can be used to create SFX for movies, stage plays, models, dioramas, model railways, and etc. Now we're going to our 10th project, serial control mode lamp. We will now use the same circuit as in project 9, but we will now delve into the world of serial communications and control a lamp by sending commands from the PC to the Arduino using the serial monitor in the Arduino IDE. This project also introduces how we manipulate text strings, so leave the hardware setup the same as before and enter the new code. That's all from me. Thank you.